All right, so today we're going to dive into something pretty cool. We're going to be talking about how to kind of ace those coding interviews, but not in the traditional way.
Mm,
Instead of memorizing a zillion algorithms, we're going to unpack this guide that I've been looking at. And it really emphasizes this idea of understanding the patterns behind the problems themselves.
right.
It's kind of like becoming a coding detective.
Yeah, it's like, you know that feeling you get when you're like solving a Sudoku and suddenly you start to recognize the patterns.
Right.
And you're not just plugging in numbers, like you're thinking several moves ahead.
Yeah.
And that's kind of the level of insight that we want to develop for these coding challenges as well.
Yeah, it's like graduating from brute force to elegance, right?
Exact.
Like instead of just, trying every possible solution, you sort of step back and you see the bigger picture. So before we actually jump into some of these specific patterns, can you talk a little bit about why this whole approach is so important? Why is pattern recognition so crucial for coding success?
Yeah, for sure. So, like, imagine trying to navigate a maze, right?
Okay.
You could stumble around randomly, hoping to find the exit, or you could use a map to guide your steps.
Right.
And recognizing patterns in coding problems is kind of like having that map, right?
Mm-hmm.
It allows you to solve problems faster. You can write more efficient code. And I think most importantly, you just walk into that interview feeling like way more confident because you've got this.
Totally. It's like having that X-ray vision to see through all the complexity and find those core solutions that are going to unlock the problem. So in this guide that we're talking about, what are some of those most common patterns? Like, what are the code cracking tools that every aspiring coding ninja should have in their arsenal?
Yeah, so this guide actually refers to them as the usual suspects,
I like it.
which I think is a pretty good way to think about them.
Yeah.
So we've got dynamic programming,
Okay.
binary search, graph traversal, two pointers, and sliding window.
Nice, nice.
So these are like patterns that you'll see pop up time and time again in coding interviews.
Okay, so we've got our usual suspects, right? It's like a cheat sheet for our brain.
Exactly.
So let's break some of these down.
Yeah, let's do it.
Let's start with dynamic programming, or DP as the cool kids call it. I'll admit this one sometimes makes my head spin a little bit. So break this down for me. What is dynamic programming all about?
Yeah, so DP can definitely seem a bit intimidating at first,
Right.
but it's really all about breaking down big problems into smaller, more manageable ones that we can solve and then like store for later use.
Okay, so instead of reinventing the wheel every single time, we're kind of saving those solutions to those smaller problems for future use.
Precisely. Yeah, so like a classic example of DP in action is calculating the Fibonacci sequence,
Right.
which can seem a bit complex at first, but with dynamic programming, you solve it step by step.
Mm.
So like, let's say you need to find the fifth Fibonacci number.
Okay.
Well, you calculate the 34th, store those values, and then you use those stored values to get to the fifth.
Got it. Got it.
So this way, you're not like recalculating the third and fourth numbers again and again.
That's really clever, yeah.
Yeah,
So we're essentially building upon those previous solutions to get to that final answer.
exactly.
Is that what's meant by those terms, overlapping subproblems and optimal substructure?
Yeah, you got it. So
Right.
overlapping subproblems basically just means that we're going to be encountering the same smaller problems multiple times.
Right.
And optimal substructure means that the optimal solution to the whole problem relies on the optimal solutions to its subproblems.
Okay.
And DP helps us take advantage of both of these properties.
Got it.
Yeah.
So it's almost like having this well-organized toolbox, right?
All right.
Where you store all your pre-built components for easy access.
Exactly.
Love it. Okay, let's move on to our next usual suspect, binary search.
Okay.
Now, this one, it's a classic for a reason, but I feel like it's often underestimated.
Mm.
Like, it's way more powerful than just, finding a name in a sorted list.
Right.
So, unpack that a little bit. What's so special about binary search?
Okay, so imagine you're looking for a specific page in like a 1,000-page dictionary.
Okay.
You would start on page 1 and flip through every single one, right?
No way, no. I would use the index, hopefully.
Exactly.
Or at least jump to the right letter.
Right, exactly. So binary search is kind of like that index. It only works if you have what's called a monotonic search space, meaning things are like ordered in a predictable way, whether it's increasing or decreasing.
Right.
But when you do have that, with each step, you eliminate half of the remaining possibilities.
Okay.
Yeah, so like if you're searching for a word that starts with S, you could immediately just get rid of the entire first half of the
Right,
dictionary.
right, right. Get rid of A through whatever M.
Exactly. And then you just keep having it and having it until you hone in on the exact word.
Got it.
And this is what makes it so efficient, especially when you're dealing with like really large data sets.
Hmm.
So like, let's say you had a million items. Like if you were to just search through it one by one, it could take you, like in the worst case, a million steps.
Right.
But binary search, maybe like 20 steps.
Oh, wow. Yeah.
Okay.
It's a huge difference.
That's a huge, huge difference.
Yeah.
Okay, so binary search, very cool, very efficient. Let's talk about graph traversal.
Okay.
Now, this one, I feel like whenever I hear those words, I'm like, ooh, that sounds complicated.
Right.
But really, at its core, what is graph traversal all about?
Yeah, it's all about understanding like relationships and connections. So think of things like social networks or maps or even the internet. These are all examples of graphs, right?
Right.
And graph traversal is basically just about how we can explore all of those connections, all of those nodes, in an efficient way.
So it's like mapping out all the possible routes on a map,
Exactly.
or like all the connections between friends on social media. Precisely. Yeah, so like an example of that would be, let's say you want to find the shortest path between 2 points on a map,
Hmm.
right? Graph traversal algorithms like breadth first search, they can help you do that.
Wow.
Or let's say you're analyzing a social network and you want to identify what are called cycles.
Okay.
So cycles are like, when two people are connected through multiple paths, like they have mutual friends or something like that, there are graph traversal algorithms that can do that super efficiently as well.
It's like having a superpower for understanding like networks and relationships.
Exactly. Yeah.
This is so cool. Okay, so we're starting to see how this is about more than just the code itself.
Right.
It's like we're actually mapping out the underlying structure of the problem.
Exactly. And that's what recognizing these patterns helps us do, is it helps us see those hidden structures.
Got it. Okay, we've got two more usual suspects to unpack.
Okay, great.
What about two pointers? That one sounds almost deceptively simple.
Right. It does, doesn't it?
Yeah.
Yeah. So don't let the name fool you. It's actually a really powerful technique. Um, think of it like having an extra pair of hands to help you manipulate data.
Oh.
So basically what you're doing is you're using two pointers, which are essentially like little markers,
Okay.
to move through an array or a string, often in opposite directions.
Oh, okay. So it's kind of like having two cursors when you're editing text instead of one.
You got it. And this is super helpful for problems where you need to compare elements within a data set.
Okay.
So like a classic example of this is like determining if a string is a palindrome, meaning it reads the same backward as forward.
Right.
So you can have one pointer at the beginning, one pointer at the end, and then move them towards the middle, comparing characters as you go.
Oh, that's so clever. Yeah, instead of having to like loop through the entire string multiple times, you can just do it much more efficiently with
Exactly.
these two pointers kind of working in tandem.
Yeah, yeah, and this pattern actually pops up in a lot of different variations.
Yeah.
Sometimes the pointers move in the same direction.
Oh, interesting.
Sometimes they're skipping elements. Sometimes they're not even pointing to like actual elements. They're pointing to like indexes or positions within the data.
Wow.
So there's a lot of flexibility there.
It's like this versatile tool that you can kind of adapt to all these different scenarios.
Yeah, exactly.
Very cool. Okay, our last usual suspect, sliding window. That one just sounds kind of cool.
Oh, yeah?
What's the deal with the sliding window?
It does sound cool. So imagine you're trying to like find the longest sequence of unique characters in a string.
Okay.
So instead of examining every single possible substring, which would be like very, very time consuming, you use a sliding window to focus on a specific portion of the string at a time.
So it's like we're taking a magnifying glass and we're kind of moving it across the string.
Precisely. Yep. And we're only analyzing what's within that window at any given time.
Oh.
And then you kind of slide that window across, maybe you expand it, maybe you shrink it, depending on certain conditions. And this technique, it's really useful for problems involving subarrays or substrings,
Okay.
or anything where you need to look at a contiguous section of data.
Got it. Got it. So it's like we're optimizing our code by just focusing our attention on the most relevant parts, right?
Exactly. Exactly.
Instead of analyzing the entire haystack, we're just zeroing in on that needle.
Yes, you got it.
Or in this case, the specific section of data that we need.
Yep. And just like with two pointers, there's like a lot of different ways to adapt and apply the sliding window technique.
Got it.
So it's another really great tool to have in your arsenal.
Awesome. So we've got our usual suspects now, right? These like powerful patterns that we can use to kind of crack the code of coding interviews, so to speak.
Yeah.
But how do we know which pattern to use? Like, I can just imagine myself, the clock's ticking, I open up that interview question, and my mind goes blank.
Yeah, for sure. It can definitely feel overwhelming, especially when you're like under pressure like that.
Right.
But one thing this guide really emphasizes is this idea of like developing your detective skills, right? It's
Yeah.
almost like you're like analyzing a crime scene, except our crime scene is the coding problem.
Okay, I like that analogy. So we're coding detectives now.
Exactly.
Love it. So what's in our detectives toolkit? Like, what are those clues that we should be looking for to help us choose the right pattern for the job?
Yeah, so first and foremost, pay close attention to keywords in the problem statement.
Okay.
Like these are like flashing neon signs often. So for example, if you see words like minimum, maximum, or like, longest increasing subsequence, it might be a pretty good hint to consider dynamic programming.
So certain words are like triggers for specific patterns.
Exactly. Yeah, so if you see sorted array or they're asking you to find a specific value within a range, binary search might be a good one. If you see things like, paths, connections, relationships between elements, well, graph traversal might be waving at you.
It's like each pattern has its own like secret language and we're learning to decipher it.
Exactly.
Okay, so keywords, that's a good starting point. What else should we be on the lookout for?
Input and output types.
Okay.
So are you dealing with a sorted array or a linked list or a string?
Okay.
Often the type of data that you're given can like really narrow down the potential patterns as well.
So the data itself is holding clues to the solution.
Precisely. And then also any constraints or special conditions mentioned in the problem.
Right.
Those are like really crucial pieces of the puzzle a lot of times.
Can you give me an example of that? Like, how would a constraint kind of point us towards a specific pattern?
Yeah, so let's say you're working with an array and the problem specifies that you need to find a solution with a time complexity of ON or better.
Okay.
Right, that immediately tells you, like, brute forcing your way through it is not going to cut it.
Right.
You need something efficient.
Right. So we need to understand time complexity, space complexity.
I guess that.
Those constraints help us kind of like eliminate possibilities.
Exactly. It's like eliminating suspects from a lineup, right?
Yeah.
You're using the information available to rule out certain possibilities so you can focus on the most promising ones.
This is amazing. I'm starting to see how crucial it is to like really take the time to analyze the problem statement carefully before we even think about writing code.
Right.
It's like we need to understand the lay of the land before we can even start like mapping out our route.
Exactly. It's about shifting from a like reactive approach to a more proactive and analytical one.
Love it. Now, what happens if we've like, we've analyzed the problem and it seems like multiple patterns could potentially work? How do we choose the best one?
Yeah, that's a great question, and that happens all the time, to be honest. Remember, there's often more than one way to solve a problem,
Right.
and a lot of these problems can be solved using, various patterns or even a combination of patterns.
Oh, interesting.
Yeah, it's not always about finding like the one right answer. It's about finding maybe the most elegant and efficient solution for that particular situation.
So it's like instead of thinking about it as like a right or wrong answer, it's more like, choosing between different routes on a map.
Exactly, yeah.
Like one route might be shorter in distance, but it's, got all the traffic.
Right,
And
exactly.
then another one might be longer, but it's like, got a more scenic view.
Right,
I don't know.
exactly, yeah. And so, like, understanding, things like the time and space complexity of different algorithms, that comes into play,
Okay.
right?
Right.
One pattern might be really simple to implement, but it might be really slow or use a lot of memory. Another pattern might require a little bit more thought up front, but it might give you like a huge performance boost.
Right. So it's about finding that balance between elegance, efficiency, and then also like the specific constraints of that problem.
Precisely. Yeah, and
Yeah.
don't be afraid to experiment, right?
Yeah.
Try different approaches. The more you practice, the better you'll get at like recognizing those nuances and making those judgment calls.
Yeah, it sounds like practice is key here, just like with any other skill.
Absolutely.
The more we expose ourselves to different problems, different patterns, the better we'll become at kind of spotting those connections and choosing the right tool.
Totally. It's like training your pattern recognition muscles.
Love it. Love it. Okay, so we've talked about the usual suspects. We've talked about our detective's toolkit for identifying them, the importance of practice. What else does this guide cover? Like, I'm ready to level up my coding interview skills even further.
Okay, well, for those who are ready to delve even deeper into the art of pattern recognition, this guide actually gives us a little sneak peek into some more like advanced techniques.
Ooh, advanced techniques. All right, you know I can't resist a good challenge. Tell me more.
So imagine combining those usual suspects to create like hybrid patterns.
Okay, okay.
It's like you're taking two classic ingredients and you're creating a whole new flavor profile.
So we're talking about like combining, say, dynamic programming with binary search,
Ah,
or like graph traversal with sliding windows.
exactly, yeah. So you might encounter a problem where, you need to find the optimal solution within a sorted data set.
Hmm.
So you might use binary search to quickly narrow down the search space and then apply dynamic programming within that reduced space.
Wow. So it's like these patterns almost become like these building blocks that we can combine and recombine to tackle these increasingly complex challenges. It's like having like a set of Legos
Exactly.
and realizing that the possibilities are kind of endless.
Yeah, that's a great way to put it.
Right. That's just the tip of the iceberg, right?
Right.
What else? What else we got?
So we also have something called pattern variations.
Mm.
Think of it like jazz improvisation, right? You have like the basic melody, but then you add your own unique flair, your own creativity to it.
So we're taking those classic patterns and we're kind of like giving them our own spin, adapting them to fit the specific nuances of the problem at hand.
Precisely. So maybe you use a slightly modified version of breadth first search to find the shortest path on a graph that has weighted edges, or maybe you use a monotonic stack to efficiently find the next greater element for each element in an array.
My mind is blown right now. It's like these patterns are just the starting point.
Right.
And then there's this whole universe of like creative problem solving that we can explore.
Exactly. Yeah, you got it. And if that's not enough, there's one more level.
Okay, bring it on.
Okay, so it's called problem transformation.
Problem transformation.
Yeah. Imagine having the ability to actually reshape the problem itself,
Oh, wow.
transforming it into something that's more familiar, something that's easier to work with.
Okay, that sounds kind of next level. So like, give me an example. How would we actually transform a problem to make it easier to solve?
Okay, so let's say you're given this problem and it just seems like incredibly complex, right? Maybe it involves like this maze of relationships, or it's just like this tangled web of data.
It's like staring into that coding abyss we talked about earlier.
Exactly, exactly. But then, like, you had this aha moment. You're like, wait a minute, I can actually represent this problem as a graph,
Okay.
right? And suddenly you've transformed this, like, nebulous, kind of scary challenge into this, like, structured format that you're familiar with.
So we're not just solving the problem, we're actually reshaping it to fit our tools, to fit our understanding.
Precisely, precisely. Or, let's say you're dealing with, like, this really long string, and you're trying to, like, solve some problem with it, and it just seems like really daunting. But then you realize, hey, wait a minute, I can break this down into smaller substrings, and I can apply the sliding window technique. Right. You've transformed the problem into something much more manageable.
It's like taking this giant jigsaw puzzle, and instead of trying to solve the whole thing at once, we're breaking it down into these smaller sections,
Right.
each of which has its own like pattern and solution.
That's a great analogy. That's a really good analogy. And, the more you practice this, the better you become at seeing those opportunities for transformation. It's like you develop this sixth sense for finding these, like, hidden structures within problems.
This is so cool. I'm realizing that pattern recognition and coding, it's not just about like memorizing these algorithms. It's about developing this whole new way of thinking. It's about seeing the underlying structure of these problems and then finding those elegant solutions.
That's beautifully put, yeah. It's about training your mind to see the forest for the trees. It's about connecting those dots, becoming this, like, more effective, more creative problem solver.
Love it. Okay, so for all those aspiring coding ninjas out there, what's the key takeaway? Like, what should they be focusing on as they're, prepping for those coding interviews and just like their coding journey in general?
I think the biggest thing is to, like, embrace the power of pattern recognition,
Okay.
right? Don't just cram those algorithms. Like, really try to understand the why behind them. Master those usual suspects, those fundamental patterns that we talked about. So those are really the foundation of, like, so much of problem solving.
Right, so we're talking about our dynamic programming, our binary search, graph traversal, two-pointers, sliding window.
Exactly, exactly. Learn to identify those clues, those telltale signs that point to those specific
Mm.
patterns, and then practice, practice, practice. Like, challenge yourself with different problems. Analyze the solutions. Think about, like, why did this pattern work better than another one in this particular scenario?
Right, and remember those like advanced techniques that we talked about, the hybrid patterns, the pattern variations, problem transformation, like those are all there waiting in your coding arsenal.
Exactly, yeah. It's like you unlock those levels as you go.
Love it, love it.
But I think, most importantly, just approach coding with a sense of curiosity, with a sense of play.
Yeah.
Like, the more you enjoy this process, the more you enjoy the process of, like, unraveling those patterns,
Mhm.
I think the more naturally it's all going to come to you.
Yeah, it's like anything else in life. Passion, dedication, a little bit of playfulness goes a long way.
Huh?
Well, that's just about all the time we have for today's deep dive into the fascinating world of pattern recognition in coding. We hope you enjoyed this little journey with us and feel equipped to tackle your next coding challenge with confidence.
Absolutely. Happy coding, everyone.